So we'll be moving on to our next talk. That's on metrics, monitoring, alerting, and troubleshooting microservices. And we have Matt Ho, who will be doing the talk. He's a consultant for 25 plus years in this industry and has worked with a lot of Fortune 500 companies and provided them solutions on the cloud. And he's also a contributor to Open Tracing and Open Census. So please welcome Matt.
Does anyone have USB-C charge I can borrow?
Sorry.
A USB-C charger? Yeah.
So do you want to wait a few moments or just go ahead and get started?
Maybe for a minute, yeah.
Okay.
Yeah, I think maybe somebody else can set down. And you are consulting at Zap Labs right now, right?
Yeah.
Is that right? Okay.
Yeah. Very interesting place. Alright. So I'll try to keep you guys awake. I know it's getting a little late, so I appreciate you sticking around. And we'll just give it one more minute. All right, I'm going to go ahead and get started. So I'm going to talk a little bit about observability, and I thought it'd be fun to start off and go to the past and kind of wind our way slowly up to the present. So observability. In the beginning, if you guys remember, we had tools like this. Show hands, anyone here remember these tools? Nagios, Big Brother, yeah, Zappix, those were the days. All right, can anyone tell me what these tools all had in common? Yes.
Health monitoring, I guess.
Yeah, we were all health monitors. Anyone else? So in this generation of tools, they had all they all shared one property, which was they were really all on the outside looking in. You know, they were tools that didn't really understand the details of the system. They would ping, they would poke, they would prod, but they really wouldn't have access to the source code. And the challenge is, if you're on the outside of the house, looking in on the house, there's only so much visibility that you have. There's only so much you can understand what's going on. And you know what? Back then, it was okay. You know, who remembers this guy? The Twitter fail whale? Yeah, so years ago, when Twitter first started, they would go down a lot. And they had many reasons, but one of the challenges they had was keeping the system up. The system was down enough that if you imagine the system in 2018 being down that often, I just don't think people would stand for it. What's happened is we've gone from a world where people were okay with this, so as down as it was, they were still fine with using the service, to a world today where Google says that even a half-second increase in latency reduces traffic on sites by 20%. Amazon has said 100 millisecond increase in latency reduces their revenue by 1%. Having the system be up and available is really important, way more so than it has ever been. So whatever the old metrics were and the old standard was, that was no longer acceptable. that pushed the industry forward. So just having a monitor poke at the system was no longer enough. Operations needed more. So the next round was, who remembers using tools like Splunk plus regex? Yeah. So the next thing was, well, we wanted some visibility into the system. What do we have access to that's already in the system? Well, logs. We can look at the logs, and what teams would do is they would take the log and they would regex the log and generate an alert potentially from that. And that alert might go to PagerDuty or whatever tool they might use. And that's how the team was able to keep a little more visibility on the system. But if you can imagine trying to monitor and maintain a system where you're trying to regex a developer's log that they've just made, that's a pretty tough thing to do. However, you know, for companies like Splunk, this was fantastic, you know, because companies would generate lots of logs. The logs would, you know, the logs would build up, and you'd need a tool. So that's where Splunk, I think, did really, really well. In fact, they did so well, you know, they had an IPO and they were all very excited. But this still didn't solve the problem. Okay. One solution that came up after this was the Elk Stack. And I think now we're getting a little bit closer to modern day. Elk Stack was, I think, in response to the pain and the expense of Splunk. Anyone here using Elk? Okay. For the rest of you folks, are you on hosted systems like Loggly or other systems? So who here is on a hosted log management system? Other folks don't have logs? No? Okay. So tools like Elk were an attempt to reduce the cost and the pain of managing these systems. But we still had the basic problem of we only were getting so much information, so much telemetry from the system. So what I think happened is this kind of introduced a new generation where we said we just have such high uptime requirements, it's no longer acceptable to try to just parse out what the meaning of these logs are, or just to ping a system to see if it's up, or check the CPU. We need more visibility. We don't want to be the person on the outside of the house looking in, peeking in where we can. You know, we want to be the person who has put cameras everywhere inside the house, so we can see exactly what's going on all the time, every time.
Just want to mention that Elastic Connect you 4 weeks back.
Ah, there you go.
We missed that slide.
Oh, okay. Right, so clearly logging was a very big thing for lots of folks, and it still is. I mean, it's by far not reached its heyday. So what is observability? I'm going to borrow a slide here from Peter Bourgeon. Hope I'm pronouncing his name right. And really, when we talk about what are these cameras that we're looking at, what is this telemetry that we're getting? At a very high level, we can divide it up into 4 basic categories, or 3 basic categories. Metrics, tracing, and logging. And the challenge with using these is that all of them are somewhat overlapping. You guys are already familiar with logging, I'm sure, and metrics. Anyone here not familiar with metrics? Okay. Tracing is probably the one that some folks have used, other folks haven't. Just quick show of hands, how many people have used tracing systems? Okay, so reasonably new. So what a tracing system does is it allows you to see inside the application a single request and all of the different services that a request has hit. So in this case, I have a sample trace here where we have the hello service. The hello service is called out to another service, maybe a gRPC service, this hello world greeter to say hello. That service has called out to yet another service, the user authorized service. And you can see here now we have multiple services all talking together and allowing us to view their conversation in one spot. So I can see this was called and this and this and this. This kind of opens up the house for us so we can really understand what's going on at a level of detail we were never able to do before, right? But to do this, as with all the other observability tools, we need some help from the development team, right? We need them to actually instrument their code. We can't be on the outside. We need them to put the cameras on the inside, and that means instrumenting their application so we can see this sort of stuff. Now, this is not the only way to view this. Datadog, for example, has their own APM tool. This is the same type of data, just formatted in a slightly different way. Here we have a request that comes in. This request calls this function, which calls this function, which calls this function, etc. Kind of in flame graph format, but it's the same basic concept. You can take a single request, crack it open, and really understand with a high degree of detail what's going on. So if you see things such as maybe there's an intermittent server problem, or maybe there is a latency somewhere in the application, but you're not sure where, once you can break it up like this, all of a sudden you can go from a situation where you don't know what's going on, you just know it's slow, to being able to understand exactly what piece in the puzzle was slow. This is a hugely important element within the whole observability puzzle. To simplify the world, there's a number of open source tools that make it easier to do this tracing. We're going to go through some a little bit later in this presentation. The first is OpenCensus. OpenCensus is based on Google's internal tool, which is named Census, hence the name OpenCensus. OpenCensus is a combination of, it handles metrics, tracing, and tagging. And then Open Tracing is another tool focused on tracing. They're both excellent tools. I've worked on them both, so I can say good things about them. Okay. So, what makes these things different? Tracing, metrics, and logs. One way to think about this, and I'm going to take an image here from JBD, who made this. It's a fantastic image. Another way to think about when do I use these things and how are they different is if I put them on two axes of how big is the data set, small versus large, and then how tough is this thing to manage? Is it cheap or expensive? You can take those three services, metrics, traces, and logs, and put them on here. And in fact, we've put metrics on here twice. But let's go into the first one. So logs, as we've seen from the Splunk IPO, the Elastic IPO, it's a very expensive service. The data sets can be very, very big. It's not an easy thing to maintain. You can see the other solutions, right? If we could take a log, and instead of running a regex expression to extract out some alert from the log, if instead we just generate a metric saying, user successfully logged in, right? That's a metric, maybe just a single value as opposed to an entire log string. We can take that really big log over there and we could reduce it down to just a single metric that gets sent up somewhere. And all of a sudden our ability to capture and store these things grows tremendously, right? For a lot less cost, a lot less effort, we can store lots of these. If we can aggregate this data, we take something that is still kind of large and we now make it really teeny. So instead of having to store every single time somebody logged in, maybe we store over the past hour, minute, day, whatever, there have been X many successful logins, this many failed logins. So all of a sudden we can take that data, which started out as log data, smash it down into a metric, and then aggregate the metrics and just sum them up. A histogram is a good example of a sum, where you just take some values over a period of time and say, here's the median, here's the minimum, here's the maximum, and you can smash it down even further, right? So you can get values even smaller. And the last one is the distributed trace. You can see it kind of falls in the middle. It's not as big as a log, but it's not as small as a metric. The value of it is, as I was showing in the previous slides, there's so much data captured inside the trace, and it's so useful, and it's not really available in any other form. Despite the fact that it's large, it's worth capturing. But still, it's still an issue, right? It's big, it's large, it's expensive. The way distributed tracing systems typically deal with that is by sampling. So in a log system, you usually generate all the logs and nothing stops them. You might turn on a different log level, but in general, once you've set the info or debug or whatever level, your system will just keep generating those logs. With tracing, it's very common to say, only sample maybe 1 in 100, 1 in 1,000 requests, maybe 1 in 10, depending on what the traffic to your system is. So if you have a low traffic system, maybe you sample all the logs. I certainly know for startup companies, I absolutely recommend that they sample everything. It's really useful to have that level of knowledge, and because the traffic volume is low, the expense isn't that bad. The reason I put this up is, in general, you want to move your data collection, your telemetry, from the upper corner down this way, because the more you can move it down this way, the more metrics you can have, right? If I had the choice of a single log line, which could print something, or the ability to capture 20 metrics, right? Things like user logged in successfully, user failed to log in, purchase was successful, purchase unsuccessful, credit card declined, all those things as different metrics. I would certainly want more metrics in the system, because more metrics gives me a better understanding of being able to see what went wrong after the fact. Right? It lets me take that data and does everyone here use a metrics presentation tool of some sort, either Kibana, Grafana, okay. Anyone not use a tool currently? How do you currently, and just out of curiosity, how do you currently, when the system is alerting things, how do you currently view it?
We have New Relic.
Oh yeah, New Relic is this, right? So it doesn't look like this, but New Relic serves much the same thing, right? It captures information and presents it. And New Relic's really nice in that they put a lot of work into, instead of making the developers do extra coding, if you're running Java, for example, they'll actually reach into your Java app as a Java agent and kind of pull information out. That's fantastic. But there are many, many ways to view this, right? So now we can start generating charts that make sense and give us a lot of detail in terms of what's going on. Yeah. But this isn't always a good thing. Because what you find is once teams have the ability to create metrics, and they can go into a tool like Grafana or Datadog to start making charts, they start making charts. And one team's charts might look like this, another team's charts might look like this, another team's charts might look like this. And the challenge is, when it's 3 a.m. in the morning and you have to look at these things and everyone's got a different chart, you're thinking, geez, how do I find the information that I need, right? You really need some sense of standardization. There's got to be some way to look at these things where it's just consistent. So when, I'm bleary-eyed and I'm trying to solve whatever's going on with the system, I would like the same information presented consistently across service to service to service. And so that requires just a little bit of thinking or changing the way we think about operations and dashboards. Historically, the application was developed down one path, and the dashboard setup, like the Nagio setup, was done down a completely different path. Okay? We don't want to have that moving forward. In the same way that the DevOps movement has taken the release process and turned it from something that operations did by itself and kind of made it something now where Dev and Ops do it together, we want to do the same thing with all the operational tools, including dashboards, including alerting. And Terraform is a fantastic way of doing that. Terraform is an open source project, and what it does is allows you to specify a configuration for almost anything. It integrates with so many providers. It gives you a way to just declare, I want a dashboard, and I think the dashboard should have a chart, and the chart should have, this metric on it. And so if you're using providers like AWS, if you're using Datadog, they're already integrated within Terraform. So as part of your projects now, in the same way that I think in the previous presentation, many of you mentioned that you were using Docker already. So in the same way that your projects now build Docker images, and that's just a normal thing, right? In addition to building the source code, you build the Docker image. In addition to doing that, your teams will get used to also building the dashboard. So the problem that has been age-old of my development dashboard if I have one, does not look like my QA dashboard, does not look like my production dashboard, right? Gets solved because now the dashboard is part of the pipeline, just like everything else, right? Using tools like Terraform is a great way to be able to do that standardization. It's just one more file that's in your project, but hey, no big deal. As with all things, all things, as you make them easier, they don't necessarily always get better. So now let's pretend we're in this world where every team has now been able to create their own dashboards. And you know, the dashboards have been standardized. But now there's a lot of teams and there's a lot of microservices. If you've ever seen the Netflix or the Uber microservice diagram, the Death Star architecture that they have, of all the microservices talking, you have a nuclear control panel of, yes, they're very regular dashboards, but there's a whole lot of them. There's no one that can actually look at all these dashboards all the time. So it's great that they're regular, so if I need to look at them, I can find things. But the reality is I want to look at them. What I want, because this is what happens if I try to look at them. What I want is I want to flip the conversation. Instead of me having to look at them, I want it to call me. So when there's a problem, tell me. Alert me rather than make me monitor the dashboard. So just like we want to encode the dashboards, we want the development teams to also encode the alerts. If you think about it, the development team is in the best position to understand what is the expected behavior of a given service. And if they're not quite sure when they launch a service, they can have more relaxed guards or relaxed ranges for their alerts. But they're in the best position, way better than the operations team is in, to understand what is the expected behavior of a thing. Right? So this is where this DevOps, the dev and the operations team working closely together is be really important. Because if the dev team is unsure, should I be alerting on this, shouldn't I? That's where the conversation can take place. All right, and so yeah, the value of that is just setting off an alert. So now I thought I'd switch over and basically show some of this as, whoa, wow, that's a really small screen. Okay, we can do this. It's really small. So I'm just going to reduce my font size. It's a little more than okay. Can you guys still see that okay?
Yeah.
So this is a trivialized example of what it takes to trace the system. Okay. The language here is Go, but the language itself is unimportant. Tracing tools exist in just about every language. You know, so whatever you use, it works roughly the same way. So what I'm doing in this case, I'm using Datadog. I just picked them because we were talking about them. I could have easily used AWS or GCP or some other provider. I'm going to create an exporter which will export my data, and I'm using OpenCensus in this particular case. So I create the Datadog exporter, I register it as a trace, and I say that, remember we talked about sampling, so we say, you know what, we're going to always sample this thing. If I don't say that, then it'll actually sample maybe 1 to 100, and so it doesn't make for a good demo if we don't actually get our trace. So the way that tracing systems work is that you start a span, and a span, based on our picture, is one of those bars that we had. So every span that I start is a bar, and when the span ends, that's the end of the bar. So here I'm going to start a new span, and I'm going to call the function bar, and bar will start a new span, and it will end. So this is a very simplistic example. It's just two functions calling each other, but there's really no difference between a function calling locally or a function calling remotely. So if I'm talking to an external service, which could be either another microservice, or it could even be a database, it could be a Memcache server, a Redis server, really any piece within my ecosystem, and I can gain visibility on how it's doing, right? Just by putting one of these traces around. And so I'll go ahead and run this. And you can see there's not a whole lot to it, it just ran. And what it's going to do in the end is publish these stats over to Datadog. Oh gosh, let me make this really small. Okay. All right, you can see I was trying this out. Sorry, I'm having a hard time finding a good size, so that seems to work. So you can see that I'm just getting these traces, and my service and resource are really just things that were in the code. So if we kind of go back quickly to the code, we can see I registered this thing as my application. I registered the service as foo, and the thing I'm calling is bar. So having said that, let's take another quick look at this. That's what you need a new message anyways. So once I can do that, I can view the trace, and you can see it's not super exciting here. We have the call to foo, and we can see that foo called bar, and we get a nice little time scale. So we can see exactly how much time these things took. The great thing is once you've given this data into a tool like Datadog, right, it can start generating high level metrics for you. Right? Higher level metrics being things like what's the average latency, what's the throughput rate, right? And all I had to do was just instrument the code. Yes? Yeah, you go ahead and ask now.
If I call a different library or function, how does it pass the context to?
Sure. So that's a great question. How does, if I call another library or function like a remote system, how does it pass the context? There's a number of common ways to do it. The most common interactions are either through HTTP or through gRPC. In the case of OpenSenses, they have a standardized format, and they also have standardized libraries in all languages, so that there's a common way to pass the data. So if I start out with a request in Go and I talk to a Java service, I can make sure that if I use that adapter, OpenSenses would call that a propagation. If I use the same propagation, then I can pass this context through. So that's both with gRPC and with HTTP. So I think in the case of HTTP, if we were to make this an HTTP server, let's see. I'm not going to remember off the top of my head. Oh, there we go. So in Go, I can write a web server like this. I can say, this thing here is HTTP handler, which is effectively a web server. And then I can wrap the web server in the OC, the OpenSenses HTTP handler. Right. And so by doing, if I had this web server, if I just wrapped it like that, it's now a OpenSenses aware thing, and will propagate the context.
How did you get that to the UI? Do I need to install something with
The UI, the Datadog. This one?
yeah, how do you send the data from your?
So this is a free account that I got from Datadog, and I'll show you what I did. I basically just went into Datadog, and somewhere in here is APIs. And I just copied, I probably shouldn't show that, so. Grab the API keys. I'll make sure to change those. And I start up a local Datadog agent, and then this app is talking to the local Datadog agent.
Is it possible to deploy this in our cluster as a local, can we run this as well?
Oh yeah, you can actually run this as locally. So OpenSenses talks to many different agents. So for example, if you want to use Jaeger or you want to use Zipkin, it will work with those tools. That's the nice thing about once you've got it into a common library like OpenSenses, you can plug in different providers. And if you want to run the provider yourself, you can. If you want to use the cloud, you can.
This is behaving same as APM tool, like database or dynamics.
Yeah. So it's such a useful piece of functionality. There's no reason to limit APM to just database calls. Right? You want to be able to use it wherever you want to be able to use it. And so tools like this really democratize access to APMs. It also drives the cost of APMs way down.
what is the differentiators between an APM and a tool like this? Exactly. Just the dashboard functionality?
So here's where I start to think of the tools as being a little different. So all the dashboard providers, like New Relic, for example, they provide an APM. In fact, Datadog calls this an APM. You know, OpenCensus, OpenTracing, they're just APIs to get your data into an APM. So it's not necessarily different, it's just different feature functionality and different price points as well. One of the key things for me, and one of the reasons I really like OpenCensus, is once you start using tracing, stats, and tools like that, you realize that there's one more piece of the puzzle that's really useful, and that's tagging. So tagging is this notion that, and you see a lot with metrics, right? So it's not enough that it's a CPU metric. It's a CPU metric for this host with this version. So there's a bunch of dimensions to it. Well, it turns out those dimensions make just as much sense in the APM world. And the dimensions, instead of being things like host, they become things like, what's the org ID that this is associated with? What is the user ID that this is associated with? And so being able to take those tags and use them in my logs, use them in my metrics, and use the same tag in my trace is a really useful thing. Just being able to share the notions. I don't have to do it over again. So different APM systems will support that at varying levels, but I think there's certainly convergence functionality. If you were to talk to the Google folks, I think they would say that the three that I just described, logging, metrics, and tracing, are really just the start of the observability world. It goes into profiling as well as debugging, right? And so, just a quick plug in for GCP. If you go into the stack driver world, you can do profiling of your running application while the thing is going without having to change any code, which is pretty fantastic. You can also set debug breakpoints in your running application, right? That is taking observability to the next level. So I think in terms of this round of monitoring, we're just really at the start of it. I think there's a lot of places it can go. Yes?
Can you suggest a good debugging tool for Golang?
Dell is a really good debugger for Golang. And it's built into, so if you use the Golang IDE from IntelliJ, it's already built into that. Yeah, so that's really good. So once you get your metrics into a system like this, what you find is they can start to generate meta metrics for you. Right? In the case of Datadog, you can see request average, you can see an error rate. In the case of tools like Stackdriver, they can show you distribution curves of your traffic. So it's really useful and very powerful. These things are just getting better all the time. And I'll just do quickly. Stats work very much the same way. So here's just a quick example of same provider, now we're just doing stats. This structure is OpenCensus, but there's plenty of stat tools. I'm almost indifferent to which one you use, just use something. So in this case, we have two stats we're tracking. One is the number of videos processed over time, and the second is the aggregate size of the size of the videos that we processed over time. And here we're saying that we want to generate a report every second. Right? So this is pretty granular. We could just as easily send the metric every 15 seconds, every minute, whatever our systems can take, or whatever is kind of interesting to the people that are looking. So what's nice is, somewhere in the code we've done some initialization, but whenever we're ready to use it, whenever we're ready to send the stat, all we have to say is, do some work, and then hit record, and we're going to record the video count of 1, and then the video size of some random integer, but you can see that would actually be the video size. And the thing is, by getting the developers now to inject these stats within the application, you get a whole new level of visibility. So think like Houston Control, right? How much data and how much telemetry is coming out of the rockets and the spaceships that we get? That's really where we're going to end up, I think. It's so cheap. This aggregated metric telemetry is so much cheaper than the equivalent log file saying, just submitted, this user downloaded this file at this time with this many bytes, right? If I did that as a a string, that'd be huge. And it's huge, not just at the time it's generated, but then I gotta store it, I gotta index it, I gotta buy the tooling for it. It's a very expensive process, right? I gotta be thoughtful about how many logs I generate, because I don't wanna overflow my systems. In fact, some companies will set quotas on how many logs a application can generate, just to keep it from overflowing the log indexing servers. All right, I think that was it. So, went pretty fast, but any questions? Any other questions? Yeah.
How does like OpenSenses like integrate with, let's say, how is it different from OpenTracing?
So there are probably a couple of main differences. The first one is OpenTracing limits itself just to tracing, whereas OpenSenses tries to tackle tracing metrics. I know they're going into logging as well. So OpenSenses is intended to be a whole family around observability, where OpenTracing is really just tracing. Probably a more important difference is wire protocol. OpenTracing is an API but not a wire protocol, whereas OpenSenses defines a wire protocol, which means that if I write an OpenSenses driver, I can define whatever wire protocol I want, which makes it harder to get two OpenSenses versions to talk together. Whereas with OpenTracing versions, the names are so close, sorry. With OpenSenses, the protocol, the wire protocol is predefined. It's a gRPC format, or one of them is a gRPC format. So when two OpenSenses systems talk together, they can negotiate what the data looks like easier.
How do you surface these metrics or metrics to the end user application?
So how would you surface the metrics to an end user? I think tools like Datadog are really great because you can give the team direct access to it, and because it's read-only. Or do you mean an end user? Or do you
End
mean
user, like, for an enterprise app, and somebody comes in, here are my metrics.
So I haven't done this yet, but I thought about doing this. A metric is nothing more than an event with a timestamp. So you can think of it as a time series. There's no reason you have to send the metric to just Datadogs or stack drivers or etc. If you wanted, you could write a mixed panel exporter. You could also write an amplitude exporter, right? And you'd see the same thing. You would see this metric arrived at this time, and all of a sudden you get a really nice marketing-friendly tool.
Makes sense for problems.
Yeah.
Does OpenSensing, like, does it integrate with Prometheus or something like that?
Yes, Prometheus is one of the default exporters that OpenSenses comes with. So you can just say, here's this, and I'm not sure I have it loaded, but all right, so. Yes, in the back.
Have you done any comparative study between the three that you listed on your talk, which are the Google Stack Driver, Datadog, and Amazon X-Ray? And what did you find if you did that study comparing these three?
So I've actually run all three simultaneously for a while.
Okay.
And I think what it turns out to be is a matter of personal preference. Amazon X-Ray versus Google versus Datadog. Datadog's gonna be it's gonna be the most expensive of the three, but they're kind of in the same ballpark price-wise. In terms of what they show, the data is roughly similar. It's the orientation is slightly different. AWS is more focused on URL paths. Google is a little more focused on integration with logs. Datadog we saw here is their kind of their flame graph world, making it easy for people to understand. I would say whatever tool you're using, just use that. The reason I would push people toward a Stack Driver or an Amazon or a Datadog really is what is the rest of your stack using? Because if you're in AWS, X-Ray, which is their APM tool, makes a lot of sense because all of the AWS services like ELBs, ALBs, API Gateway, etc., generate an X-Ray trace ID, if you will. So it integrates very cleanly within the system, right? So if I'm running a serverless architecture, all of a sudden I can do the tracing without needing a separate agent to do anything. You know, likewise, if I'm in Google, the same is true. Or if I've got a hybrid or heterogeneous environment, you know, Datadog, that makes a lot of sense too. So that they're not, the thing about standardizing a library like OpenCensus is if they all support it, then they all offer roughly the same thing.
Can you give the presentation?
Yes, what's that?
Can you give the presentation?
Oh, sure. Yeah.
If you can send it to me, I'll share it with.
Okay. All right, if there's no other questions, thank you very much.
Thank you, Matt. Thanks a lot. Very informative. So we have this room for up to 9 o'clock. If people want to stay back and network a little bit, or if you want to get home back quickly, that's fine too.
Nice meeting you.